Given a system of nonlinear equations, let's call the first equation A. That is x squared plus y squared equals 5. And equation B is x squared plus 4y squared equals 14. Those are definitely not linear equations, because linear equations would have y to the first and x to the first in it. These have y to the second and x to the second. So we're going to find the solution, and the method we're going to use as instructed in note 119 is we're going to use elimination in a way that's convenient. So just examine the problem, and it looks like a good thing to do would be first to take equation A, step 1, and solve it for the variable x squared. Not x, but x squared. So solve A for x squared. And once we have that, x squared expressed as a function of y, we'll plug it into the other equation to eliminate the y's, or rather the x's. Okay, so let's do that. Take equation A. It is x squared plus y squared equals 5. And all we have to do is subtract y squared from both sides. We get x squared equals 5 minus y squared. Okay, now let's do step 2, where we take that result and substitute into equation B. And watch what happens. Here's equation B. It's x squared, which I will not write. I'll just write in place of x squared 5 minus y squared, because that's what we just learned in step 1. That's the same as x squared. And then I'm going to write the rest of equation B, plus 4y squared equals 14. Okay, so now I'm happy because I have an equation that only contains y's and no x's. So let's get rid of the parentheses and see what we have here. 5 negative y squared plus 4y squared equals 14. So let's see, let's go 5 minus y squared plus 4y squared equals 14. And we'll move the 5 over like this, subtracting. And let's combine the negative y squared and positive 4y squared. Together, that would give me 3y squared. Positive 3 times y squared equals 14 minus 5 is 9. Now let's isolate the y squared by dividing both sides by 3. Whoops, see my error, that should be y squared, not y third. And so we get y squared equals 9 divided by 3 is 3. And then we want to get just y, so we get y equals plus or minus the square root of 3. So I'm going to put a cloud around that. We found 2 values for y. And what we need to do now is find the x partner to each of those y's. That will be step. Well, actually, we should have had a step 3 in there. Let's see. Substitute. Like, in here, let's put step 3. Solve for y. Okay, so we did that. So now step 4, we need to find the x partners. So that is actually not too difficult. We just take each of those y's. Over here we'll have y equals the positive square root of 3. And next to it we'll have y equals the negative square root of 3. And we'll plug those individually into equation, let's say equation A, to find the partner. So equation A is x squared. Well, I should say equation A modified, which is this guy down here with the star. Let's use him because he's already solved for x squared. So let's go x squared equals 5 minus y squared. But in place of y, we put the square root of 3. And of course, over here for equation A, we'll have x squared equals 5 minus parenthesis negative square root of 3, close parenthesis, squared. Because if in that second one, we are using y equals negative square root of 3. Okay, back, let's work all the way through the left side. When we square the square root of 3, we get x squared equals 5 minus 3. Okay, because the square and the square root cancel one another. So we got x squared equals 2. And that implies that x equals plus or minus the square root of 2. Meanwhile, on the other side, what happens when we square a negative? When we square a negative, it becomes positive. And then when we square the square root, it eliminates it. So here we have x squared equals 5 minus simply the square root. I'm sorry, not the square root. It's just simply 3. 3. The square and the square root canceled, and the minus canceled with the square because it was an even power. So x squared equals 2. So we get the same thing. X equals plus or minus the square root of 2. So step 5, we're going to draw our conclusion. Remember, we're looking for ordered pairs that satisfy both equations in the system, and we found a bunch of them. We actually found 4 of them. Let me list them all. These are ordered pairs xy. Square root, that's a positive square root of 2, with a partner, positive square root of 3. Okay, that's one ordered pair. Another ordered pair would be positive square root of 2, comma, and negative square root of 3 for the y partner. And another one would be negative square root of 2, comma, paired with y equals positive square root of 3. And finally, negative square root of 2 paired up with negative square root of 3. So we have 4 ordered pair solutions to this system of nonlinear equations.